But let me back up a little bit and just talk a little bit more about matrices and some simple algebraic operations involving matrices. It turns out that you can add and subtract matrices. You can multiply matrices. The only thing you can't do that you could do in scalar algebra, you can't do division. But the other operations you can do using matrix algebra. So let me just briefly explain that. It's very simple. Actually, let me just add one more thing. There are two types of multiplication. You can multiply a scalar times a matrix, and you can also multiply two matrices times each other. So there's actually two types of multiplication. Chang almost always denotes matrices using capital letters, like capital A, capital B, capital C. Okay. So let's follow that convention. If you want to add or subtract two matrices, they have to have the same dimension. Okay. So assuming they have the same dimension, you can always do addition and subtraction. For example, suppose matrix A, let's pick something simple, 2 by 2. Let it be a 2 by 2, and let's just pick out some numbers arbitrarily. Pick out some numbers for me. Not too big of numbers. 7, okay. All right, and it's all right for them to be 0 or -2. Anybody else got another number? 0, okay. Somebody besides Ben. Yes, tell me your name. Oh, is it Brittany? Yeah. I'm sorry. -2, that's fine, Brittany. -2. All right, one more. Somebody else? 3. Okay, well, let's do 3. All right, and let's add that to matrix B. Now, in order to add matrices A and B, they have to have the same dimension. Otherwise, you can't perform the operation. So let's let B also be a 2 by 2. And give me some more numbers. 5. 4. Who said 4? And you are Hal? Yes. 3. 2. All right. Now, this is so simple. What would A plus B equal? You can add A and B because they have the same dimension. And what is A plus B going to equal? What would be this first number, first row, first column? 12. You just add the 7 and the 5. So you get a 12 here. What would the next element be? First row, second column. So it'd be 0 plus 4 is 4. The next element, the first column of the second row. What? So it'd be -2 plus 3, 1. And then the last element would be 5. Okay, that's matrix addition. Obviously, you could also do subtraction. If we wanted A minus B, then let's just change this to be A minus B. We would have to change these too. What would the resulting matrix be? What would the first element be? Anybody? Yeah, 7 minus 5 would be 2. The next element in the first row would be -4. 0 minus 4. The first element in the second row. Okay, -2 minus 3, -5. Very good. And the last element would be 1. 3 minus 2 is 1. Okay. All right, now you know how to do matrix addition, matrix subtraction. Okay. Now, if I wanted to try and trick you up on an exam, I might ask you to add a 2 by 2 matrix to, say, a 3 by 3 matrix. Say A is a 2 by 2, but B is a 3 by 3. Then what would be the proper answer? Can't do it. You can't do it. This operation is not defined. Okay. Because the matrices, what the book uses would say the matrices are not conformable for matrix addition or matrix subtraction.